introduce Dr. Spaeth, who's an associate professor at Rutgers University. I know many of you have met with her today. She's been busy all day. And just to give you a little bit of her background, if you don't know it already, she did her bachelor's in psychology at Elon University, master's in experimental psychology at the College of William and Mary, and went on and did a master's in behavioral science. She did a postdoctoral fellowship at neural research. As an experimental psychologist, and has dedicated herself to a career health outcomes with a focus on a number of publications. She's got eight review papers, 8 book chapters, a number of invited talks, and in 2021 she got an R01. Yay. So yay. She belongs to the Obesity Society and also the Sleep Research Society, and was also the Sleep Research. And she is currently a member of an NIH study section, review section on addiction risks and mechanisms. So thank you for taking the time out of your schedule and coming to speak. Bye.
Thank you for having me. I'm an introvert, so I think I did more talking today than like the last month. And it was nice. It was so fun. It was great to be here. So thank you so much for having me. I hope we'll continue a lot of these conversations because I just learned and was so interested in what everyone was doing. So it's been really great. So I'm a sleep person, so I like to start with where we're at and a reminding of all of us of where we are. So we're on a ball flying through space, and we happen to rotate around our axis every 24 hours. And that happens as we take a year-long trip around the sun. And all of life on Earth has evolved since the start of this 24-hour rotation or axis. And so everything on Earth has evolved with a light-dark cycle. And this is critical for shaping our behaviors. So we as humans are diurnal. So we are active during the light cycle and we sleep during the dark cycle. And our waking activities are primarily comprised of eating and moving, right? And you can think about moving in the sense of exercise and what it does for fitness, but you can think of movement also from the perspective of exploration of the environment and moving through where you live. And these behaviors, these 3 behaviors, are critical for what makes us human and what comprises our health. And so it's awesome that your department covers diet and exercise, or nutrition and exercise, and it's great that you're starting, to include sleep and invite me here. And maybe someday your department will be sleep, nutrition, and exercise, but we'll see how things go. So the primary signal that tells or keeps our biology aligned with this light-dark cycle of our environment, it is light. So light signals come in through special receptors in the eye. It turns out it's not just about rods and cones, right? We have an additional cell that's there specifically to detect light levels. And that transduces the light signal into an electrical signal that's read by the brain that then releases melatonin, determines core body temperature, and that's all orchestrated by the central clock which is located in the suprachiasmatic nucleus, which is part of the hypothalamus. And then that central clock coordinates with peripheral clocks. There are clock tissues in various peripheral systems throughout the body. But in addition to light, and light is the most important, we call it a Zeitgeber, a timekeeper. We know that your food intake, which again is a critical human waking behavior, that also plays an important role in keeping time and keeping your clocks aligned with your environment and with each other. And we also know that movement plays a role. So you have sleep and you have activity. And so moving, being active during the waking period is also important for your physiological and behavioral rhythms. So as you are having this sort of circadian cycling of these rhythms around the 24-hour light-dark cycle, we also have various homeostatic processes happening, right? And you're probably very familiar with it from a food intake perspective, right? That you have this satiation or satiety buildup, and then it dissipates, and then it goes up again. It's very similar with sleep. You wake up in the morning, you're not very hungry for sleep, right? You've just had a nice long meal of sleep. And as you're awake throughout the day, your drive for sleep increases. Right now, you might have a pretty high drive for it, especially if I'm boring. And then at some point in the evening, that reaches a peak, and then you fall asleep. And then that drive dissipates and the whole thing starts again. And in an ideal situation, these two processes, which we call the two-process model, are working in beautiful harmony. You're sleeping during the dark cycle, you're awake during the light cycle. Now we know we've started to work out some of the circuitry that underlies the switch. You can think about sleep-wake like a light switch. Awake is on, sleep is off. Think about, as humans, we spend maybe 1 to 7 minutes a day in a in-between, where you're not quite awake and you're not quite asleep, right? You're in that kind of like middle zone, but that's not very much time. For the most part, our biology is beautifully orchestrated to create these consolidated states. You're either asleep or awake. And it turns out that's comes down to the brain and how it regulates sleep-wake cycle. So we know that there's an ascending arousal activation system that goes from the brainstem through the thalamus and hypothalamus and out to the cortex. And when these nuclei are active, it's promoting wakefulness. It's promoting the lights being turned on. And then you have this beautiful area, the preoptic area, that's very GABA and ghrelin heavy. And when that area is active, it sends inhibitory signaling to all of the key nuclei that are in this ascending arousal system. And it tells them to quiet. And so it shuts down that ascending arousal system. So when preoptic area is active, the lights go off. Now, any good system has backups, right? And it turns out we also have a backup, and that's kind of where orexin comes in. So orexin, which is released from the lateral hypothalamus, promotes nuclei in the ascending arousal system. It's saying you're awake, you're doing stuff, stay awake, be active, be awake. And then when the sleep area turns on, not only does it inhibit the ascending arousal system, but it also tells orexin to quiet because it needs to make sure that all of that excitatory input is quieted. And what's so great about orexin is this is where you see this beautiful connection between sleep and waking behavior, right? When we're awake, it's associated with getting calories, right? That's a key important active behavior that you need to engage in to survive. And so you see that hunger and satiety affect orexin signaling, and they're very tightly linked with sleep. So I don't know if any of you have pulled an all-nighter. Never, right? Because we're all so good at time management. But if you start to eat, you may notice it might be harder to stay awake. Whereas if you stave off and stay a little bit hungry, you might find it's a little bit easier to stay alert. And that makes sense, right? Like if an animal is starving, it's going to try and promote some alertness to give the animal a chance to find more food. And after Thanksgiving, many of us retire for a nap, right? Because we're nice and satiated and the body says, you can rest now. You need to rest to digest all the food, right? And so we see it over and over again in the neuroscience and in the behavior, where what we eat, when we sleep, how much we move, they're all so tightly integrated. And when they're working together, it's this beautiful, harmonious, healthy system. So this was work by Jerome Siegel in California, and he went and found a few tribes that are still living as hunter-gatherers, so traditional, like how we evolved to live. And he looked at their sleep. And so he had members of the tribes wear an actigraph, which is a wrist-like, watch-like device worn on the wrist that captures movement, but also light. And what you're seeing here is different seasons. These are the three tribes two tribes in the sun he looked at in the summer and the winter. Here's another tribe in different seasons. And what was fascinating was that their sleep duration was not significantly longer than what we're doing. So everybody's worried we're not sleeping enough. But when they looked at the sleep in these tribes, it wasn't much more than 7 hours. That was pretty typical. But what they did see was that there was seasonal variation, right? So they slept longer in the winter and shorter in the summer because their temperature isn't always perfectly controlled. Their light exposure is much more natural. And so the sleep period was much more tied to sunrise and sunset, such that the sun would set, there would be a lag, and then they would have their sleep period. And the wake would usually happen around sunrise or immediately prior to sunrise. So that meant the sleep period was completely isolated to the dark period. And you can see that for the most part, many humans, they're still sleeping after sunrise, right? And the timing of our sleep or the consistency of our sleep is vastly different. Our light exposure is so different than what you see here. You see, they're outside all day. They get access to this beautiful sunlight to their system throughout the day. And then there's no artificial light once the sun has set. And the sleep is really tied to that, the timing of that. They didn't. They were surprised. They thought maybe, and in the summer, you saw sometimes after like midday, they would stay in the shade of a tree and sometimes nap, but there was not a lot of napping. They did not even have a word for insomnia. Didn't know how to talk about it. Obviously, very low cardiovascular metabolic issues here. Their diet is extremely healthy. And I think they average something like 17,000 steps a day or something. So very active, even into old age. So older members of the tribe remained very, very active. But that's not us, right? Unfortunately, we live in a very different society where once we created artificial light, that further allowed us to create 24/7 societies where businesses run no matter what our biology tells us the time is, right? And we're exposed to a lot of light at night. And if you think about light, you might think it's been around for a long time, but it hasn't, right? When you think about human evolution, from 315,000 years ago, we've only had light for about 150 years. Our brains, our bodies are not yet adapted to really account for artificial light. So things feel old, but they're not. And we are not adapted to them. And I don't have to tell this room any of this, but clearly it's not just light that's, not ideal for our biology. Our work now is very sedentary. Our access to calorically dense, ultra processed foods is 24/7. And now what we're seeing with the sleep is that there's direct exposure to light stimulation immediately prior to trying to go to bed from the light that's emitted from screens. And so when we're talking about obesity and we're talking about metabolic disease, you can't really understand it without thinking about sleep, nutrition, and exercise as the three primary health behaviors that comprise everyday life. Okay, so that's, I hope you're at least sort of buying my argument that there's critical relationships between these three. So I'm just going to share with you to start some work that I did at Penn. I think some of the students have read this paper, so they might remember it better than I do at this point. But what we did is we were interested in recruiting healthy adults that were normal sleepers. And we asked them to come and live in our lab for 2 to 3 weeks. And during that time, they were randomized to different conditions. We had a control condition that had 10 hours time in bed per night for sleep each night. And then we had 3 different sleep restriction conditions. In all 3, they started out with 5 consecutive nights where sleep was restricted to 4 hours time in bed per night. And then they were further randomized to get either 1, 3, or 5 nights of recovery sleep, where after that, they recycled back into a second sleep restriction exposure, 5 nights, 4 hours time in bed per night. And then before they could go home, they needed to finish up with recovery sleep. So we were interested in doing this because it somewhat mimics a busy work week where you don't have time to get a full night of sleep in because you're up late working or you have other things going on. But then maybe you do have a chance to recover for a weekend or a lighter week, but then you have to go back into a work-heavy week. And what we found, just looking now, focusing on those first 5 days of sleep restriction, I thought was really interesting. So this is when they wake up after a baseline night of sleep and they go to bed at a usual time. Then this is waking up from a full second baseline night of sleep, but now they're staying up until 4 a.m. because they're going into the sleep restriction period. They're in their sleep restriction period, but this day here, they wake up, they've been sleep restricted for 5 consecutive nights, but we put them to bed for recovery sleep that night. And then this is subsequent recovery. So what it shows is that in terms of caloric intake wasn't increased more with more sleep restriction. It wasn't as if there was this buildup of the homeostatic drive for sleep that was increasing food intake as it got more and more significant. What was really the predictor of caloric intake was bedtime. What time are you going to bed that day? How much wakefulness are you experiencing that day? It's not how much sleep debt you're carrying into the day that's impacting food intake. It's how much time are you spending awake and how late is your bedtime? And then we had the control group for comparison. And when we looked at the timing of intake, the white bars are the baseline. And we found that when you're sleep restricted, the subjects in this study consumed about 500 extra calories during the late night period, where we kept them awake instead of allowing them to go to bed. And so what happened was, in a normal situation where you're going to bed at 10 p.m., the majority of your calories are in the earlier part of the day. You've had breakfast and lunch, right? By the time it's like 3 o'clock. But what happens when you delay your bedtime and you're extending your wakefulness for that day now you're consuming this large amount of calories late at night. So you're shifting when you've been consuming the majority of your calories till later. And then when you wake up the next day, you're not quite as hungry. So you don't quite eat as much at the first meal the next day, but it's not enough to fully compensate for the increase in caloric intake from the late night meal the night before. And then when I looked at what were they eating, it was not fruits, vegetables, and salad. So they were living in what we kind of created like a home-like environment. They had a kitchen like you would have a kitchen at your home. They had access to food from the hospital that we would bring in. And before I would bring anything in, I would weigh it and, you know, organize it so I could track who was eating what. And so they consumed a lot of salty, sweet foods that are more processed, but more pleasurable to consume. Okay, so what happened with the rest of the protocol? So as I said, during the first bout of sleep restriction, we saw an increase, and that was consistent across all 3 of the sleep restriction groups. Then when there was recovery, caloric intake came down here. And then during the second bout of sleep restriction, caloric intake went back up. And it didn't matter how many days of recovery were between the 2 sleep restriction periods. Caloric intake went up about the same amount during the second sleep restriction period. And again, this supports the idea that it's not your recent sleep history that matters. It's not how much sleep you've been getting the past few days. It's more how late are you staying up that day and what's your bedtime that day? How long are you staying awake with access to food? And the late night caloric intake was similarly consistent across the 3 conditions. So it is this late night consumption of calories that's driving the increase in daily intake. So why? Why are participants consuming so many additional calories during the late night period? It's accessible, right? So first of all, it has to be there for them to be able to eat it. But we know that we live in an environment where that's the case for most people, that if they're awake, there's food available to them. But we also know that there are changes in hormones that control appetite, like ghrelin and leptin, when there's sleep restriction. So we didn't do these studies because our food intake was ad libitum by design, but other studies that controlled for food intake have shown that sleep restriction increases ghrelin and decreases leptin to some degree. And so there is sort of this drive, hunger drive happening. We also know that there's circadian rhythm to hunger ratings. So in this study that was done by a group at Harvard, what they did was they removed all clues of time of day. The participants were kept on a very fixed meal schedule. Light was controlled. They had no idea what time was. So they started running on their own internal clocks. And they had them rate their hunger every, hour or so. And then they were able to see if there was a circadian rhythm to hunger. And they found that the peak hunger occurred at 8 p.m. and the trough at 8 a.m. So it seems like when you're delaying your bedtime, you're staying up later, you're awake for more of this heightened hunger effect. And so if there's food available, you might be more prone to eat. We also know from some neuroimaging studies that sleep restriction or total sleep deprivation can impact the brain's response to food cues. So food cues may become more salient or more rewarding when you're in a sleep restricted state. So I think of this as, maybe you're driving home from the lab really late. If you feel very well rested, it might be just a little bit easier to drive past your favorite fast food sign and keep on going. But if you're very sleep restricted, it just might be harder to make that decision. And then another option might be this just decrease in self-control, when you're sleep restricted, behavioral inhibition might just be more challenging. You might not have the cognitive effort available to do that. So I just showed you sort of group average data. So then I was interested in looking at if there were differences amongst our participants in terms of how they responded to the sleep restriction. And so I looked at gender and race, and I found that men increased their caloric intake more than women during the sleep restricted period. And I did not see a difference between African American and white participants. So I did not see a race difference there, but I did see a gender difference. And when I looked at the intake of calories, the timing of the intake of calories across the day, there were no gender differences at baseline. But when they went into sleep restriction, it was this late night meal where men really consumed more. They consumed a greater percentage of their daily caloric intake during that late night period compared to women. Okay, so then I wondered, well, okay, what about even within these gender groups? Is there individual variability here? And so we were lucky that we had a couple protocols running that had a similar schedule with the 2 baseline days and the 5 sleep restriction days, and then a recovery day. And our participants could come back and participate again if they wanted. You might be thinking, who would want to do this twice? But we did have some people that wanted to. And so we were able to bring back 19 people where they would have completed 2 of our protocols. This was separated by the shortest duration was 60 days between the 2 participations. The longest was 5 years. So they came back after 5 years and did another sleep study with us. So what I did was I wanted to see if their caloric intake response would be similar between the 2 exposures to the protocol. And what we found was that late night eating was pretty stable. So what does this plot look like? So each of these letters is a participant. These are the men and these are the women. And then one of their exposures is the squares and the second exposure is the circle. And the y-axis is their late night caloric intake. So you can see here that this subject, T, she didn't consume calories late at night. So we kept her awake, she was sleep restricted, but she just chose not to consume any calories during the late night period. And she behaved the same way both times she came. Whereas this participant, also very stable, but consumed quite a high number of calories and did so on both occasions. And it was similar with the men as well. So it kind of goes from lowest to most caloric intake on average between the 2 exposures. So there's something happening here where there's a somewhat of a phenotype where certain adults are more susceptible to overeating in response to being sleep restricted, whereas others are somewhat resistant to this effect. And this is not specific to caloric intake. We see this over and over again. When you take a healthy adult and you put them through sleep restriction, some people fall apart. They can't stay awake. Their mood is terrible. They can't remember anything. Maybe they overeat. And then other people just keep on going. Like there's no problem. They're at the computer doing the cognitive tests. You know, they're remembering things, they're fine. And they don't seem to know that they have this power. It's not like they've ever thought about it, but they're super human.
Night owls versus.
We don't see differences in chronotype. We don't see gender. Race doesn't predict it. Age doesn't. So I looked at that here and that didn't for food intake. And it's not always the same. So like this woman here, she was resistant to the caloric intake side, but maybe she falls apart from an attention standpoint or a memory standpoint. So different people excel or are having issues in different areas. Yeah. So I published my dissertation that I spent 5 years of work on. And then I look at marketing and I'm like, they knew it already, right? They had it figured out. And I found out the person that started Insomnia Cookies was at Penn. Like he went to Penn. It's like, we should have been talking, right? I love the Taco Bell one because they just say it exactly what it is. It's a fourth meal. It's this meal between dinner and breakfast. If you're awake, you're going to go for this fourth meal. And it made them a lot of money, probably. So I just want to kind of summarize so far what I think is happening. I think we evolved to experience sleep restriction occasionally for various reasons. And if that was the case, it was probably because we needed to be moving, we needed to be expending energy, and that something about that triggers an adaptive response to seek out calories, to try and compensate for that additional energy needed for whatever it is that's keeping us awake instead of allowing us to sleep. But that no longer becomes adaptive when we're living in an obesogenic environment, right? Because now just spending more time in an obesogenic environment is not going to be helpful. It's going to make it so much harder for us as humans to resist overeating. And especially if we're not moving and we're not burning those additional calories, because now we're sleep restricting ourselves to finish up our grant, not burning a whole lot of calories doing that, right? And so it becomes this maladaptive response. And I think there's just something to be said for time. How do you use your time? You have 24 hours. If you're sleeping, you are not able to be spending that time eating, right? And in this obesogenic environment, that's actually a good thing. That's helpful for us, is to be spending more time away from this environment that's not good for our health. When you're awake, you just have greater exposure to food cues as well because they're available everywhere. And so it's the homeostatic responses, it's the reward responses. All of this makes us more prone to obesogenic behaviors that over time can promote weight gain. And indeed, population studies consistently show that adults who sleep less than the recommended amount of 7 to 8 to 9 hours a night, they're at higher risk for obesity, type 2 diabetes, and cardiovascular disease. But keeping all of that in mind, we do need to remember that there are group differences likely in these relationships, as well as individual differences, probably based on genetics and other biological factors. Okay. So I had been doing that work, sleep restriction work, as a PhD student at Penn. And then I started a postdoc at Temple. And I was interested in looking at other reasons that as humans, we experience poor sleep during the lifetime. And one of those times is the postpartum period. So I was at the Center for Obesity Research, and there was a trial going on for women who were socioeconomically disadvantaged. So they were on WIC, which is like a food stamp type program for women and their children, racial ethnic minorities. And it was an intervention to try and help them with postpartum weight management. Because in this particular group, what was happening a lot was after delivering their babies, a lot of these women either wouldn't lose the weight that was gained during pregnancy, or in fact would gain additional weight during the postpartum period. Whereas most women who are more socioeconomically advantaged typically lose or come back closer to their pre-pregnancy weight. So we started out collecting actigraphy on these new moms, mostly single moms. They wore the watch for at least a week. And then they would come in afterwards and we would ask them about their sleep because we would see the actigraph output. And I couldn't believe how, I don't know how they were doing it. I mean, it was like, it was, and you'd ask them, do you remember what you were doing on Tuesday? You know, it was like from 3 to 5 a.m. It looks like you were awake. I don't even remember. I can't remember. Yes. Going to the laundromat, right? Going down the street to the laundromat. So, so this, I just wanted to show this because this is what we were talking about when it averaged across the sample. So the average total sleep time in these women was only 6.6 hours. 92% of them were, you know, short sleepers. And there was a lot of wakefulness after they would go to bed. And this, by the way, this is at 5 months postpartum. So it's not like right after, it's 5 months postpartum. And the sleep efficiency in particular. So if you go to get a sleep study and they're worried about your sleep, usually 85% is like the clinical cutoff for sleep efficiency. If you're below 85%, which means that once you're in bed for sleep, you're not sleeping for more than 85% of that amount of time, then you're usually referred to a clinician, right? And so the sleep efficiency here was 77.5%. And I looked at another paper that had come out similar time, but in a very different sample. These were majority white married mothers who were well educated and above average income. And their sleep duration in the first 4 months postpartum was pretty good at 7 hours. The efficiency was not great, right? Because all new moms know the efficiency. You're not going to stay asleep when you're asleep, right? It was about 80% 2 weeks postpartum, but over those weeks, as the baby gets older, there's more time between feedings, their sleep efficiency improved to about 91% at 4 months postpartum. So in these moms, very different moms, their sleep was shorter by almost an hour, and their efficiency was not showing the same levels of improvement. It only went from 74 to 78%. And not only that, but the sleep was associated with their weight gain from 5 to 12 months postpartum. So again, not in the immediate postpartum period, but going from 5 to 12 months after having their babies, we saw that women who had obesity, who were short sleepers, gained additional weight during the postpartum period. So that those sleep problems were having implications for their metabolic health. So we followed that up with a study, with the same study, but looking at, can we figure out maybe what's predicting the sleep for these moms? Like, is there anything we could maybe intervene on in a future study? And we did see some things pull out, and unfortunately, some of it's not, you can't intervene, right? Moms with multiple kids who were single parents were at higher risk for short sleep. Interestingly, those who were breastfeeding had more likely to have short sleep. And breastfeeding in this community is an issue because the WIC program provides baby formula, and a lot of them feel pressure to just go to formula after having the baby. And so then when they try breastfeeding, they find it hard to find resources to help them get better at breastfeeding and make it an enjoyable experience. So perhaps more resources to help these moms with breastfeeding might then improve their sleep. Bed sharing with an infant was also not great for sleep. But we have to be careful how we talk about this, right? Because certain cultures, it's very common to share your bed with your infant. And so trying to figure out that balance between protecting the mom's sleep and helping her, but also knowing that this bond is so important between the mom and the baby. One thing we found that I thought was funny as a mom, so we asked moms, how do you respond when your baby cries at night? And the moms that said, I just go in immediately, I go help, they had poorer sleep than the moms that said, I can go wait a couple minutes and give them a chance to, be upset. So there's a lot of conflict, I would say, on like Instagram sleep baby sleep experts about cry it out versus not cry it out. But turns out a couple minutes maybe would help mom sleep a little bit better. And then for them, going to bed after midnight, so them delaying their bedtime was not good for their sleep, because they weren't able to then sleep in to compensate for that late bedtime. And then employment. And this is where we get more into policy, right? So having to go back to work at 5 months, by the time they were 5 months postpartum, probably much sooner than that, negatively impacted their sleep. So somehow, if we can get these moms more protected time, we might see better health outcomes. Okay, I know I'm running late, but the last thing I want to talk about is pregnancy, because this is another time for yay women where we have a little bit of trouble with our sleep. And so this was a study that my graduate student championed, and she was really interested in physical activity levels or exercise routines in pregnancy. And she's a CrossFit person. She's very believes that women can do resistance exercise during pregnancy safely, and that it actually might confer a lot of health benefits. And so we were going to do an intervention, and then COVID. So we modified it to just be an observational study where we compared more sedentary pregnant women to women who were physically active. And what was interesting is that we did not see any differences between the two groups. And this was done in the early third trimester, so getting pretty sizable by that point. We didn't see any differences between groups in like objective measures of sleep where we use the ActiWatch. But we did see a difference in how they perceived their sleep. So women who were physically active rated their perceptions of sleep quality better, because lower scores are better on the PSKI. So they perceived their sleep to be of better quality compared to the women who were not physically active. And then she was interested to kind of go with this idea of being physically active, looking at protein intake. So we compared the pregnant women who met guidelines for protein, which I'm going to get this wrong, but it's like 1.1 grams per kilogram body weight per day, compared to women who did not get enough protein. And that's where she saw some differences in objective sleep. So the pregnant women who were meeting protein guidelines had better sleep efficiency, less wake after sleep onset, and longer sleep times. So perhaps diet might be another way that we can help women improve their sleep. Things like targeting, making sure they're getting a sufficient amount of protein in the diet. We also looked at fiber, but we did not see any differences between groups. But one of the problems with fiber was like so many were not getting the recommended amount. So the sample size was quite low for that group. So that I still think that might be something to continue to look at. And then overall, we saw that actually lower carb and higher fat intake associated with a longer sleep time in this group, and that greater fiber overall associated with an early bedtime, but didn't affect sleep duration. And we did not see a relationship between saturated fats with either of the outcomes. Okay, so I think I saved time for questions, but thank you so much again for having me.
So it does look like there's people on. Or do you think it could be or changes? And then about the physical activity. And I'm really interested in what. And does that offset at all?
Yeah, so there have been studies done in like metabolic rooms where they do like 24 hour, and they look at a day with a normal night of sleep compared to a day of short sleep. And you do, so when you're awake instead of asleep, your metabolic rate is higher. So you're gonna burn a little bit more when you're awake, even writing a grant, than if you were going to bed. Yeah, or watching TV, yeah. You don't have time for that. So, and so there is that effect that could then trigger this response to like, you're burning more calories, you need to eat potentially. But it's just, I'm trying to remember the exact number. I think it was less than 100 calories.
Not enough to offset
No.
the things like your illness.
Exactly.
Here's your thing about this. I think there's anything else going on, so I'm thinking about like fridge and that sort of thing. Do you think that would be good?
Yeah, so in sort of a different, I'm going to take it a different way a little bit. In a study of overweight women, they came in and they did 2 weeks of normal sleep, and then later they came back and did 2 weeks of short sleep. In both conditions, they calorically restricted the women and saw weight loss. But what they saw in the sleep restriction group was less fat loss. So it's something where when you're sleep restricted, you're clinging to fat a little bit more. And that's been replicated now in another study that was done more like outside the lab in the real world. So I think so. I think that.
Actually study out.
Okay.
Think about night shift workers. If they're a security person, then she's walking around all night versus it's somebody sitting at a monitor watching a security camera.
Yeah.
Like better.
Yeah, very different.
One more quick question. So I would imagine that would condense. You're going to be getting.
So what happens when you restrict sleep is you conserve the slow wave sleep, the deep non-REM sleep that happens at the beginning of the night. That you conserve. What you lose is all the REM that happens at the second half of the night. So it's interesting. It does alter. You're not getting that second half of the night, and I think that has implications for metabolic health and also obviously cognitive functioning and memory, things like that. Not sort of, yeah. Some of them would sort of do that. They would have, but we tried to keep it very open. So I can't say it was a systematic change. You know, everyone just kind of did had their own way of dealing with it. And they, you know, humans are just so funny because they were run in groups of 4. So they weren't run in isolation. So we don't know too, like the group dynamic of being with other people, and they would often just sit in a table together at meal times. So maybe even if you didn't want to eat, you wanted to sit there and talk with others. We tried to keep it very, just let them eat as they wanted to. I know that doesn't answer your question, but
No, because what I'm thinking is, so if it were me, and obviously I'm a nutrition scientist, it's
yeah.
but and I knew that, you know, I'm going to be up longer during the night, I might like push my breakfast by an hour, and then my lunch is late by an hour, and dinner, and that way I probably won't eat.
They were not that strategic.
Strategy.
Yeah.
For me, depends on participant baseline nutrition knowledge of how to.
Yeah. I would say probably not. They didn't have a lot of that. Yeah. Thank you.
Recovery from sleep nutrition intake was reduced for baseline levels.
Yes.
What do you think?
I think, I'm sure it's partially like the homeostat, right? Trying to maintain, but I think it's also like the additional sleep, less time awake.
They're oversleeping for 5 days.
Yes.
Less exposure.
Yes. Yeah. I think it's both. And I think when we lived outdoors, they go together. I mean, we didn't have this separation of temperature control with the light dark cycle. It's all together, you know. Mhm.
If they were premenopausal.
Yeah. Yeah. The subjects were 18 to 40. So the women were, we did not restrict recruitment based on like, contraception or anything like that. We did have them log it, and it was not a great estimate. Women don't, they're not great at that. But from what we looked at in a rough way, we didn't see it having a large impact. But that's not to say that it doesn't have an impact. I think we have a long way to go to understand what's happening across the menstrual cycle with sleep.
Yeah, so do we know in women if sleep changes across the menstrual cycle?
Yeah, so when you break it up between like pre and post ovulation phases, there are differences in like core body temperature and that affect the circadian rhythm. And you do see differences in sleep ratings, subjective ratings. You don't typically see objective changes in sleep as we measure it with sleep architecture. I think there could be physiological changes happening that women are picking up on and perceiving that we're not able to see in our EEG necessarily. I think we're missing, there's some, maybe autonomics, I don't know, but something is different.
Their perception is that their sleep is worse.
Oh man, I'm not going to answer because I don't want to get it wrong
Yeah.
because I can't remember.
I can't imagine.
My
Yeah.
mention is, but were you including subjects who had baseline like healthy number of hours of sleep?
Yes, we were recruiting normal sleepers. Yeah.
Normal sleeper is also somebody who goes to bed at the same time. So it's not somebody who says, I get 8 hours, but I go to bed tonight at 10 o'clock, sleep till 6 in the morning, and tomorrow night I'll go to bed at 1 in the morning and sleep till 9. It's they gotta go to bed at the same time. So factors to that.
And this was recruitment before TikTok. I think it was a lot easier then.
Sorry for getting another question.
Yeah, I think that definitely would hinder the sleep if they're having those hot flashes. I think there's a lot happening in menopause that's going to impact the sleep. And there is some evidence that the hormonal replacement therapy can be helpful for women's sleep as they're going through that transition. But again, we have a lot to do in that area. Yeah, there's a lot of interesting stuff with sleep apnea that we were talking about as it relates to menopause.
Postpartum sleep.
Yeah, so they didn't report any depression.
Really?
Not really. But I don't think this sample of women, when you give them these measures, I don't think it's picking up on what they're experiencing necessarily. I think we need to do more work on developing measures that are for those kinds of populations.
Specific to
Yeah, because they're just not responding. And I'm not suggesting they're all depressed. They might be fine, but I just think we gave a couple measures like that, and it was like, really, like they just don't really respond. They're not. I don't know. I just don't think it's captured.
Data. I might have mentioned this before, but Dallas, our study, which is 4,500 people in Dallas. They compared the timing of activity of women and men. And it's absolutely hilarious that on the weekend, and these were people with 2 jobs, everybody was busy, these were lower income. And on the weekend, the men's activity would just plummet and the women's activity just went up. And it was such a clear signal of, it's the weekend, I'm doing the laundry, I'm going shopping, I'm trying to get ready for Monday. And just as a social, these were African Americans and Hispanics, and it was unbelievable to see the difference. And so to me, now add a baby to that.
Yeah.
Yeah.
I think it also comes to your point that we had in class today that was discussed about, they also perceive that as normal.
Oh, yeah.
Yeah.
So what happens is when you give them a questionnaire that's not super sensitive, they don't report something that is, that I'll call
That's
that
just my
normal
life.
behavior. That's just the way my life is,
Yeah.
so it doesn't show up. you know?
And it's what everybody I'm around,
That's right.
everybody's dealing with these things and,
Yeah.
yeah. Now, I don't think we gave anything like that in our study, but that's a really good, I don't know. I don't know of a measure like. Yeah, of resiliency. That's, I'm sure there are, but I don't think we gave them in the study. Yeah.
Okay, well, let's finish. Oh, you've got one more, Megan?
Just a super tiny one. The study with for the wealthy white married women, they have nannies helping them.
Well,
Yeah, but I don't know in that study, but they, or maybe mother-in-laws or,
Yeah.
yeah. So, I mean, they were getting good amounts.
Okay, let's thank Dr. Spaeth.